Human perception, cognition, and behavior exist in a constant state of flux. Every thought, reaction, and memory continuously blends and dissolves into the next. This creates an immediate problem for traditional scientific observation. You cannot put a thought on a scale, and you cannot measure a memory with a ruler. Psychology is left with a massive scientific roadblock. Researchers are tasked with objectively testing theories about experiences that are entirely subjective. To move past this subjective observation, psychology had to integrate itself with an entirely different, highly rigid scientific discipline. Understanding the mind requires establishing a strictly reliable system of measurement. This intersection, where the fluid nature of the mind meets the rigid laws of mathematics, is the field of mathematical psychology. The core mechanism driving this field is a technique called mathematical modeling. Modeling functions as a translation tool. It takes abstract psychological concepts and converts them directly into quantifiable data. This translation process forces researchers to abandon vague theories. They must define their ideas and lock them into strict, bounded systems. By applying rigid mathematical rules to human experience, researchers strip away subjective bias to reveal clear, testable patterns. We can see exactly how this translation works across three primary psychological domains: perception, cognition, and behavior. Take perception, like recognizing a visual shape. We measure the exact intensity of that stimulus and convert it into a single input value, x. Next is cognition. If we track memory processing speed, we can quantify that delay as a temporal metric, t. Finally, behavior. The ultimate choice a person makes based on that stimulus is calculated as a probability output, p. Researchers then map out exactly how these distinct variables influence one another. The culmination of this process is unifying these distinct domains into a single functional formula. This resulting equation now represents one isolated, highly specific psychological process. Researchers can mathematically alter one variable in the equation, like artificially lowering the processing speed, to calculate exactly how the predicted outcome would change. Forcing human experience into these rigid variables creates a structural blueprint of the mind that can be relentlessly stress-tested. This structural blueprint generates a crucial asset for researchers: precise hypotheses. A traditional psychological approach might guess whether a certain behavior will occur. The mathematical approach predicts exactly how and when it will occur. This chart compares those two approaches, illustrating the ultimate goal of the field: empirical validation. On the left, a traditional theory creates a wide, fuzzy predictive area. On the right, the mathematical model generates a sharp, single trajectory that perfectly intersects with hard data points. This level of validation allows psychological theories to be tested against reality with the exact same rigor used to test the laws of physics. Mathematics operates as the required engine for mapping and proving the hidden mechanics of human nature.